Hello and welcome to another lesson in the Designing VMware Infrastructure video training series. In this lesson, we're going to be discussing incorporating implementation and test plans. In this lesson, we'll start out by examining implementation planning, including a look at why it's necessary and beneficial for an architect to include implementation plans in his or her design. Next, we'll discuss creating an implementation plan and look at what's included in an implementation plan. Following that, we'll transition into test plans by looking at the need for test plans, reviewing the types of testing and test plans, and documenting the results of your testing. Are you ready? Let's get started. So far, we focused on creating the design, but creating the design is only part of the picture. Creating the design doesn't answer some questions. It doesn't answer what are the details in how this design is going to get implemented. It doesn't answer the question, if multiple ways exist to implement something in the design, which way should we use? By providing an implementation plan, you, the architect, are addressing an important aspect of the design that answers these questions. Now, you might be having some thoughts running through your head right now, perhaps one that looks something like this. Implementation, but I'm an architect. Implementation of the design is someone else's responsibility. While you might potentially be correct in that in many instances a separate team of individuals will actually conduct the implementation, it is important to understand that including an implementation plan in your design offers a number of benefits both to you, the architect, as well as to your organization or your customer. Let's look at those. By including an implementation plan in your design, several benefits are provided to the architect. One, it reinforces the holistic approach to the design by providing another viewpoint that you must incorporate. You've incorporated the holistic approach by looking at how the different technologies are related to each other. This allows you to continue that holistic approach by looking at how implementation affects the design or how the design affects implementation. The same goes for looking at how implementation affects operations and how operations affects implementation. By maintaining this holistic approach, by maintaining and reinforcing the broad view, your organization or your customer benefits because the design is better suited to their environment. Second, it allows the architect to provide specific details on the installation or configuration of specific parts of the design where those details can be valuable. This is particularly true when multiple ways exist to implement a particular feature specified in the design. By not specifying these details, you, the architect, are leaving an area that could potentially influence and impact the rest of the design, but you haven't accounted for that. Providing an implementation plan allows you to account for the potential impact that that implementation details might create. Finally, it allows you or affords you, the architect, a greater level of influence over the specifics. And in some cases, those specifics are important because different ways of implementing things might have different levels of impact on your design. By addressing all the potential areas of impact on the design, your customer or your own organization gets a better, more solid design to implement. Now that we looked at why implementation planning and including an implementation plan in your design is necessary, let's look at creating an implementation plan. At a minimum, your implementation plan should include things like installation guidelines for your ESXi hosts if you're not using AutoDeploy, configuration guidelines for any supporting infrastructure. This could be Active Directory, DNS, or perhaps if you're using AutoDeploy, configuration guidelines for things like DHCP, PXE, and TFTP. Your implementation plan should also include hardware configuration guidelines, such as setting up blade chassis, setting up rack mount servers, configuring onboard administration functionalities, such as those provided by a variety of vendors these days. Where applicable, you'll also want to provide storage configuration details, network configuration details, and information on implementing OS templates or guest OS images. Who is your target audience for this plan? Your target audience for this plan is going to be the actual operators, administrators, or engineers who are responsible for physically conducting the work to implement the design. This could be your customer if you are creating a design for a customer and you're going to pass off to them, or it could be another team within your own organization who will then assume the responsibility for implementing what you've created. Now, normally, I would love to show you an example of an implementation plan. However, each implementation plan is so specific to each individual organization or customer that if I went through and sanitized it to take out customer names or partner names or anything else of that nature, it would almost destroy its value. So unfortunately, I can't show you one here. But there are examples available, and I'll show you some resources where you can potentially get some examples in another lesson in this course as we talk about preparing for your VCAP DCD exam. Now let's transition into a discussion on testing and test plans. The primary purpose of testing is to validate or verify that the design does what it's supposed to do. In other words, you've created a design that says, this is what we're going to do. We're going to provide X megahertz of CPU power and X gigabytes of RAM and the ability to run VMs and deploy new VMs and connect to existing networks or create new networks or whatever it is that the design factors led you to create. And now we're going to conduct some testing that's going to verify and validate that what you've created actually does what you said it was going to do. Thorough testing can only validate that the design does what it's supposed to do, but it also can uncover unexpected design impacts. While we maintain and strive to review every single design impact and to address them, the reality is that we're human and we might miss some. So through testing, we can identify unexpected or unanticipated design impacts. We can also reveal any potential weaknesses in the design. As you can see then, by acting as a validation or verification of the design, test plans are a key component that you'll want to include in your comprehensive VMware design. Now, there are a number of different types of testing that exist. Functional testing verifies that the design works as you expect it to work. Performance testing, on the other hand, is intended to identify that the design meets any performance-related benchmarks. This might be true for performance-oriented SLAs, for example. Availability testing, or perhaps you might refer to it as failure testing, shows that the design responds as expected and appropriately to various failure scenarios. Finally, you can also conduct what's called acceptance testing to indicate whether or not the design can be accepted or operated by the target users, your customer or your own organization. You'll ideally want to incorporate as much testing as is reasonably possible and let the design factors be your guide here as they have been throughout the design process. If availability is a primary concern for your organization or your customer, then you're going to want to make sure that your availability testing is comprehensive. If performance and performance-related SLAs are a key part that your organization or your customer's organization is concerned about, then you're going to want to make sure your performance testing is thorough and comprehensive. Another part of this testing is not only understanding the types of testing that we can perform, but how we go about documenting the testing. Let's look at that. There are really three key parts to documenting your testing. First, you're going to document the specific tests that will be conducted. This could be things like, I'm going to fail a server and make sure that vSphere HA or vSphere FT operates as anticipated. These could be tests like, I'm going to shut down part of the storage area network and ensure that storage connectivity is not negatively impacted. You're also going to want to document the expected or anticipated results of the testing. When you perform this test, what do you expect is going to happen? When you shut down that blade, what do you expect will occur? When you shut down part of your storage area network, what do you anticipate the results will be? Then, after the testing is actually conducted, you'll want to record the actual results of the testing. Between the expected or anticipated results and the actual results, you can then perform a gap analysis, and the gap analysis can tell you where and how the design might need to change, if at all. What I'd like to do at this time is actually show you some testing documentation that I created as part of my own VCDX design. Here you can see a document that I have pulled up. This is the design verification document that was part of my VCDX design. And in here, I have a series of tests and documented information. For example, one of the first tests that we documented and conducted here was a test of the network redundancy of the management console. And so here we provided the specific steps involved in the test, details on what's involved in that step, what are the specific things that you have to do. This ensures that the test is repeatable and predictable. We then have expected results. What you don't see here, since this is just the test plan, are the actual results that came from this testing. That's found in a separate document. And you can see that we've continued this through testing vMotion, testing VM network redundancy, testing VMware or vSphere HA operation, testing storage redundancy, and at each point we provide specific details so the test is repeatable and predictable, and then what our expected results are. We would have a separate document that then records the actual results of the testing. More examples on vSphere DRS operation and then VLAN connectivity. I have one piece blacked out there. That's a customer name that I want to maintain anonymity here. So this is one example of some test documentation. Let me show you another example. In this document, what you see is actually a redundancy analysis for the storage area network for the design that I created. I went through each potential component in the path of the storage area network, from the virtual connect modules in the back of the chassis, to the storage area network switches that existed, to the ports on the mezzanine card itself, the ports on the storage controller, and the actual storage controllers, and documented what would happen if there were a failure in that component, and then how mitigation could occur if mitigation was necessary. Notice that in this analysis we actually identified a single point of failure, and that was the mezzanine card. The particular blades that were included in the design, which were a design constraint, by the way, meaning that we had to use those blades in this design, only had a single mezzanine slot available for fiber channel connectivity to the storage area network. And that meant that if the mezzanine card failed, there would be an outage, and there was no mitigating that. There was no way to get around it. So this was an example of how we identify potential risks, and that is a failure of a mez card creates an outage, and mitigate the risk where possible. In this case, it wasn't possible because of other constraints that existed. The testing and the test documentation is what revealed this potential single point of failure. Now that I've had a chance to show you some actual test plan documentation, let's wrap up this lesson. We first talked about examining implementation planning, and especially talked about the need for an architect to include implementation plans in his or her design in order to have a comprehensive and complete design. Next, we look at creating an implementation plan and examined what's involved and should be included. From there, we transitioned into discussing the need for test plans and testing, reviewing the types of testing that you can and should conduct, and then documenting your test results for inclusion in your design. That's all for this lesson. Thanks for watching.